Hey everyone, so this is Yijia. So today is the last day of the Whitepaper walkthrough, and thanks for keeping interested in Origo and then keep listening for this like serious talk. And today's content will be the last part, and we'll focusing on like our security guarantee and our like a token design and just like a basic token design and our roadmap. And the token design and the roadmap may have like some change or some tweak, but yeah, mostly will be that. And I may have other stuff to talk, and because I always want to talk about like a different trust model, different like other like implementation ways, comparison or like those stuff. I'd like to share, but it's not that related to the white paper. So I may have like other talks in the future, and but yeah, today I'm mainly focusing on the last part of the white paper. Okay, so we just like give you some like overview back to remember what is Origo's protocol. So Origo's protocol is like a first step is try to uh, commit the commitment to the blockchain, and then commit the encrypted data to the blockchain and your proof to the blockchain. The proof is more like a proof the proof a zero knowledge proof to prove your commitment is which is matching your encrypted data. So and the second step is the blockchain or trying to verify whether your commitment actually matching um, the encrypted data, and then if it's matching, and this before the open period, you will send the information to the executor, and then the executor will do the calculation based on all of the inputs because it's encrypted by his public key. So he will like do the calculation, and then at the settle step, will send back the result by encrypted by like a participant's public key, and also generate a computation proof back to the blockchain. And the blockchain will verify the computation proof. Okay, this is correct, and then you will deposit, send back the money or like uh, distribute the coins. So this is the basic protocol. So let's talk about the security guarantees. So we need to like say this is like a multi people like join the contract, right? And usually it may associate with like multiple participants. So we need to at least ensure the fairness of all of the participants. So there's no, let's say there's no one can say to have any relationship with the executor so they can win the game. We want to prevent that. So it's more like you commit the inputs and the execution are separate to two steps, right? So when the commits end, none of the participants can actually change the input anymore. So so even for the against each other game, you will keep the fairness. So by this kind of protocol, so no one can actually be. I mean, no one can be the friends of the executor and then cheating on the result, cheating on the inputs and then win the game. There's no that possibility, because when you before do the calculation before starting the smart contract, no one knows each other's like inputs, and then or when then yeah, even the executor doesn't know each other's inputs, and when they commit the inputs they cannot change anymore. So by this way you will like, keep in the fairness. And the second is like we want to ensure the execution completeness for like parties. So it's more like so the no none of them can actually change the execution result. So it's more like the computation is done by the executor. Even he let's say even the executor it's one of like a participant's friends or even the same one. He know all of the inputs. and then he say, okay, I will generate some other execution result. I will change the result to be something like I want. That's impossible, because this like zero knowledge proof is like verifiable. So if he changed the result and given something wrong, he cannot generate that kind of proof. So it's more like he cannot find a proof to actually prove his like a wrong result. So that means like none of them can actually change the execution result. So if like the executor as a friend of the one of the participant, and before executing the result in the open stage, he may want to like abort to prevent the loss. Let's say, for example, there's like a rock paper scissors, and then someone already put a rock, and then I know that my commitment is scissors, and then I definitely will lose if I open it to the executor, and then the executor tell me that, okay, this another guy he puts a rock, and then I know, okay, definitely I will lose. So I refuse to open to the executor. Then we actually adding the model to say there's a deposit. So if you abort to prevent this kind of lose, right? And then the deposit will be charged anyway. So in this way, it's more like it's a design principle to help a developer to actually think about. It's like if he refused to sending out outputs, you'd better design some like a deposit model to actually charge him. So otherwise, it's like if he is a friend of the executor, then he may cheat, right? So this is the guarantee for that. Say no one can actually, if this is like a deposit model, you cannot change your commitment, but if you refuse to sending the encrypted data to the executor, then there's some deposit you will lose. And the third is like then actually the participant won't have the motivation to actually abort the contract, because otherwise he will lose the deposit, right? And for the executor part, we also want to guarantee the execution completeness. So which means like the executor can do is like the executor cannot change the result, because otherwise he cannot like generate a right proof. So what he can do is like he can abort, right? He can. So if the executor abort, which will means this kind of the protocol at the last step will stop, right? And then people have to start it again, which is bad. So what we will do is like make the executor need to like deposit some deposit, and if he quits, then his deposit will distribute it among to all of the participants. So it's like the participant will get some money back, will get some money back to like in return if the executor doesn't do his job. And for contract that with high availability requirement, let's say if the developer wants the contract to be really high like availability, and then he wants to he can like set up like multiple executor to actually running the stuff. So the backup executor mechanism is designed. So it's more like he can like specify to multiple executor, and then let multiple executor do the same job, and then to guarantee, let's say, even one of the executor is abort, the job can still be done. And yeah, we may also like using some like a key management mechanism to like sharing the data actually doesn't need to be like starting the protocol again from like commit and then everything again. There may be some like a key sharing mechanism to actually keeping this easier. Yeah. So, and then we talk about the cryptonomics design. So this is not the final version, but the basic idea is there. So our Origo token it's like a use for like rewards and also for punishment. So this is like a basic design principle, because usually like token are just using for rewards, right? And then so So for like basically the token serve as like similar to like a gas fee function as ETH on Ethereum. So it's more like you use the functionality, you pay some like money, right? The transaction fee or like the gas model, the gas cost, something similar to that. So in advance, it could be served at like four rows. One is the deposit, so which say I'm an executor, and then I need to make some like deposit to say to ensure my ability, because otherwise I may like either like offline, you send me the data and then I go like offline, or like say I get the data but I don't do the calculation, right? So which is bad for executor and other behavior tracking. So this kind of deposit, let's say um, you can refuse to generate this kind of proof or something like that. Yeah, it's more like a deposit to behave as an executor. And then also for like a deposit for participants, let's say the participants may commit the data but then refuse to open, and something like that. But this can be designed by a developer because this is not mandatory, because it's more like for different kind of contracts. Some contract may need the participant to make deposit. Other contract may not. Just like if you quit, just quit, right? So it doesn't need to actually have deposit, but you can use for as a deposit. And for rewards, it's like a rewards for executor. When the executor down the job, right, generate the proof and then send him the proof back to the blockchain, he can get some rewards. And also for like validation nodes, the validation nodes need to like verify this kind of to creating new blocks and verify the proofs, and also maybe validate the public public transaction or private transaction, or validate the public smart contract similar to Ethereum. Those like job will get rewards, right? And you can use to serve as a payment stuff. It's like you can use as a currency. You can use to pay like the transaction fees or like or serve like that. And they also like serve as as can be used to as a like a punishment, because like a bad participants will lose portion of or all their deposit for like certain rights. All their like certain rights will be taken away for like a behave badly. So it's more like your deposit will lose, or like a part of the deposit will lose, or say uh, or like losing some like that for like behaving bad. So this is the like the design principle for the cryptonomics design. And so for our roadmap, it's like we plan to like issue ERC20 token, and recently it's maybe end of this month or like early next month or something like that. It will issue the token first. We'll start with like a as a ERC20 token, so like people can easy to change or like easy to exchange, switch or something like that. Yeah, and at the end of this year, like December, we'd like to launch the like the testnet release, and the testnet release will with the function to enable to do confidential transactions, and also we can enable smart contract. So it's more like you could think about it's like it's like a Ethereum normally public contract stuff, but plusing the confidential transactions. So it's yeah, and at the let's say the mid of September of next year, we'd like to plan to launch the mainnet, and at that time we're gonna need to burn the ERC20 coins to start Origo token, and then convert it, and then at the end of next year, we'd like to enable the building privacy preserving smart contracts, all of the functionalities, and then with our like templates. So like for lots of like contracts, we will start first with like collaborating with some like some companies or like collaborations, and then we will like announce some building templates for the smart private preserving smart contract, and to launch on that. And then the 2020s, like June of 2020, we're gonna need to enable the developers to create their own like a private preserving smart secure verifiable smart contract. So I think again, you say all of the building tools will be ready. So you don't need to actually follow the templates. You can like imagine whatever you want to actually do the stuff. So as I mentioned, it's like the roadmap may change, and there may be some little trick on it, and then so yeah, so like keep patient on this. So thanks for listening to the white paper walkthrough. This is like a 10-day stuff, and then um, as I said like before, I'd like to like give more talks about like Origo stuff or like technology related to like a blockchain in the future. So feel free to actually keep looking or keep interested in Origo, and then look for the news. Yeah, thanks.